Natural deduction solved problems. The first problem. Derive for all z r0 z y from for all x r0 xy. This is a kind of change of bound variable, but we have to prove that it is correct. So we write the assumption for all x r0 xy and below it the desired conclusion for all z r0 zy. As a first step, we eliminate the universal quantifier by substituting to x a term that is free for x in the formula, and z is such a variable. So we get r0 zy. And now we can introduce a universal quantifier, because z does not occur free in the assumption for all x r0 xy, which is the only assumption of this derivation. So the universal quantifier introduction rule can be applied, and we get for all z r0 zy. Second example, we derive for all y for all x r0 xy or r1 y z from for all x for all y left parenthesis r0 xy or r1 y z right parenthesis. There's a lot of similarity between the assumption and the conclusion. It is just that the universal quantifiers have swapped their places. Note that there is one free variable z in this formula. So we first write the assumption for all x for all y left parenthesis r0 xy or r1 yz right parenthesis, and below it the desired conclusion for all y for all x left parenthesis r0 xy or r1 yz right parenthesis. This deduction is quite easy. We simply eliminate the universal quantifiers and then introduce them. So first we eliminate the universal quantifier for all x and note that x is always free for x. Then we eliminate the universal quantifier for all y, noting that y is always free for y. And now we start introducing. We first introduce for all x, and x does not occur free in the assumption. And then we introduce y, noting again that y does not occur free in our assumption. And the deduction is ready. Next example. We derive for all x p1x from for all x p0x and for all x left parenthesis p0x implies p1x right parenthesis. Let us write down the assumptions for all x p0x and for all x left parenthesis p0x implies p1x right parenthesis, and below them the desired conclusion for all x p1x. The idea is that we eliminate the universal quantifiers and we get an implication p0 implies p1, and on the other hand we get p0x, and then we use implication elimination to get p1x, and then we introduce universal quantifier. This derivation is of the type: we know that everything is in p0, and we know that whatever is in p0 is in p1, and we try to show that everything is in p1. So we take a completely arbitrary x and we eliminate the universal quantifiers for all x by substituting x. X is always free for x, so it is fine. And we get p0x, and on the other hand we get p0x implies p1x. By implication elimination we get p1x. And now we note that we took a completely arbitrary x. X does not occur free in the assumptions. It is just the opposite, x occurs bound there. So about this particular x that we have chosen, the assumptions say nothing. So we can use the universal quantifier introduction rule, and we get for all x p1x as we wanted.